All right, we're climbing out of our snow day backlog here, and I have half of exciting news, good news, news. I find it exciting and good. 5-2 is almost available, and I've changed the due date. So it is almost available. I have all the questions down. I need to do one last run through because I need to reduce the risk of error to a certain degree before I'm comfortable with it. You know, I'm not quite getting at Six Sigma level of quality assurance here, but I need a minimum level of quality assurance. So I've given myself till tomorrow at noon, and so it'll become available till tomorrow at noon. I've changed the due dates because it's originally due this Friday. This Friday was going to be 5-1. I pushed that back because it was going to be due last week. This Friday. And 5-2, but 5-2 isn't even ready at the beginning of the week here, so I pushed it back till Tuesday of next week. So you can work on 5-1 between now and Friday, because it's due February 2nd. We'll talk about that today. And then we'll go over, if there's any time today and or Wednesday, 5-2 material and the quiz. And we can even go over it a little bit Monday if we need to. It'll be due Tuesday. And then we'll be back on track, I think. Next week we'll hit right on the schedule of Module 5 on Chapter 6, Part 1 in the weighted average method. So we're getting caught up there. That's a good sign. And the fact that it's already a lot of new questions, a lot of overhaul of that test bank for 5-2. So we are in 5-1 line, which is standard ABC, and some of the questions I call it normal ABC. It'll be pretty obvious what I'm talking about because the point is it's not one of the weird versions that we get into in 5-2. Call them weird, but they're different. So actually, I'll leave student view for now and go back here. Let's just go in and talk about some of the questions we can see in ABC. And so ABC has a few different steps to it. First stage allocation, in which you take overhead accounts that are on the general ledger. Thank you. There we go. I'm just in the Google Sheet that's shared. You take the overhead accounts that are in the general ledger. You get a percentage table. I'm in the screen now. You get a percentage table from an ABC study. That's where a good portion of the cost of ABC comes from. It's the initial startup cost, at least. Figure out how those overhead accounts correlate to activity cost pools. You take the activity driver, the budget activity driver, and with cost pool in the numerator and the driver associated with that cost pool in the denominator, you can get an activity rate. And that really is the end of the first stage allocation. So now you have a bunch of drivers and the rates at which they charge units or jobs or orders as they consume those drivers. Second stage allocation. I didn't have numlock on there. I think that was my problem. No, I did the F2 problem again. That was a problem. Our second stage allocation, we take the activity rate that was handed to us from first stage allocation. We see actual cost driver consumption, and we multiply the activity rate by the cost driver consumption, and then we have our overhead allocated to the cost object. I'm going to call it, I'll just say job or order at this point. And then we can add direct costs as well. I'll put direct costs there, and then I will say total costs now. The idea is you take these two together, add them to get total costs. Now, there are questions on 5-1 that hit here, that hit here, that hit here, and that hit here. I'll ask for the total cost for a job, I'll ask for the overhead cost for a job, how much overhead is allocated. I'll ask for the activity rate. With percentage allocation, I might ask some questions about how much is this activity cost pool over here. There are also ABM questions. Nope. Activity-based management. This is the general setup for these kind of questions. You need to use some sort of ABC information to determine the cost of a particular customer or a particular process or the business as a whole or a particular product line. And then that helps you evaluate alternatives. Sometimes there'll be process improvements. There are like 4 different process improvements you could make, and you have to choose which one's the most profitable. And you make a decision based on the information from ABC. So activity-based management, you're doing management decisions, which we kind of skimped over. We went through relatively quickly in chapter 2. We didn't ask any questions. There was no quiz for chapter 2. We went over it in class, the 4 archetypal kind of questions. Set up a table where you have alternative 1 and the profitability of that, and alternative 2 and the profitability of that. So you have this relevant cost analysis table. That's very similar to what we're doing with activity-based management. It's just that the costs that go into that table are driven by our activity-based information, all this stuff we've learned in chapter 5. Usually the textbooks or the consulting books that are pushing for activity-based costing include this element of it, because this is where a company regains the money it lost investing in an ABC system. So it spent a lot of money doing an initial study and any follow-up studies over time, because you know that the percentages change over time, and having a portion of their accounting information system to track the numbers here and then allocate costs separate from its GAAP accounting to make decisions. It costs a lot of money and time and effort, and some opportunity costs is involved in there too. You know, accountants working on this can't be working on other things they could be doing for the firm. And then the idea is you earn that back by making better decisions on the activity-based management front. And if you aren't going to, then it's probably not worth it to adopt ABC. You don't just want to know the information for knowing the information. It doesn't keep you in business for very long. So let's look at some of these questions. And so, for example, here's a question. Looks like I give you activity rates. We kind of go back here. I started you here. I started at the beginning of second stage allocation, and I'm asking for the orders allocated overhead costs. So I'm asking you to go from here to here. Give you the activity rates. You need to get the overhead that's allocated to the job or the order. All right, let's look at this question. Let's label this. This is ABC problem general setup and typology. Ooh, we'll get fancy here. And first question, this is we'll call it second stage allocation question. We'll make sure we hit some ABM questions for sure. I often get questions about those. They're kind of a horse of a different color. They come out of left field when you're thinking, oh, activity-based and rates and cost pools and drivers, and then there's a question about Bubba's shrimp, and you're just, what in the world is going on here? But it's related. All right, so this question, Forrester Corporation, we have our 3 here. Let's see if we can get those over. Well, kind of. I'll just copy them over like this so we can use those numbers. And then I'll pull apart and move this over. We have our order has these direct costs, and I'll write them down. They're red herrings in this question because it's asking for overhead cost, so we don't need to add the direct costs. That would be right here. It's asking us to stop right here. but I'll keep them there. Maybe we'll use them someday. A different question. We have 4 setups, 2 batches, and 8 direct labor hours. This sentence right here. And it changes from version to the question, one version of the question to the other. But the activity rates also change, apparently. Oh, I put them sideways. I need to put them down. This is going to make this easier because I believe we have it in the same order. Setups, 4 setups. We have 2 batches. There's our batch rate. And we have our direct labor hours. Or we have 8 direct labor hours, and we consumed, we have a rate of $19 per direct labor hour. All right, great. So we have these 3, and some of those is going to be 198 down there, and that is going to be our overhead cost. So great. That's correct. If we said, oh, but I know eventually you have to add those direct costs. That's part of the order's cost. Times. Good for you, but you would answer the question incorrectly because this is the total cost of the job, and that is incorrect for this. Okay, questions on that one? Second stage allocation is pretty relatively painless. I can say that for it. Good. So much so, I kind of want to skip over this one. I will say it doesn't give you activity rates. So we are looking for total cost. We'll go back over to our setup here. It is asking for total cost, and you don't have activity rates. So you do have activity cost pools and budgeted activity drivers. So I can put budgeted here. So you have to use those to create rates for these 4 activities, and then use those rates to allocate overhead to cost or to job 8B right here. And then it's asking for total cost. So should we add these in or not? Yes, thank you. Great. Add those in. Those are direct costs. They're part of the total cost. Excellent. I'm going to skip it over it. Skip over that one. This one is asking you for total cost as well. Looks like you also have to go from here down. So I'm asking you for a good chunk of the process in this one. I've spared you the situation where you're doing percentage tables on this question. And I'll kind of skip over that one too. We can come back to it if we want to. I want to make sure we get to this kind of a question right here. All right. So this is a more comprehensive question, which asks you to start from here and go to here. Because we have GL accounts right here. And that's all we have. We don't have activity cost pools already. We don't have activity rates. We have to start from scratch. Oh, messed it up again. I am never going to be able to retrain my F2 instincts, I think. The cue that knows I at least need to do first stage allocation, of course, is the fact that there's a percentage table. The only time you have that is if you're involved here. So it's very likely that I'm going to have to do that part. And then when I look down, it says it's asking for the total job cost. Yep, that means I'm going to have to go from here all the way down here. Some questions just ask you, stop there. This one's very comprehensive. And each micro step is pretty simple in its own, but there are different forks you might forget and choose along the way. So seeing it all together helps. It's good practice for us. So let's copy this over. I think this will copy cleanly. Great. And I'm going to take, I want to copy. There we go. All right. Now I want to take the admin GL amount, the budgeted admin cost. I'm going to make that absolute times our percentage right here. And so we're moving that across our different, in fact, I didn't want that. I want the column absolute, because then I can just go down and now we'll get the shop supplies cost. So in case you're trying to double check, we still have a total of 1 million administration costs and 600,000 shop supplies. And we can make it pretty, so we double check. Yep, those are the numbers. And now we've got, I don't want that. Stop. We've got our activity cost pools for the deconstructing activity and the disintegrating activity. I'm not sure what kind of business this is. This is very suspect. But Wise Guys PC does disintegration and deconstructing as two of their value-added activities based on the cost study, and they consume these GL accounts like this. So now instead of these two GL accounts that are overhead that we don't know what their relationship is with individual product units, we now have these activity cost pools based on these three activities, other being a period cost, which is not going to get allocated. But these two are inventoriable costs, product costs that are going to get allocated to products as they consume the cost drivers that are associated with deconstructing and disintegrating. I don't even name the cost drivers. I just say, this is the deconstructing cost driver or activity driver, excuse me. And this is the disintegrating amount, the amount of the disintegrated budgeted activity cost driver. So I'm going to put those in where they go. Right here. They're going to go right there. This is the budgeted activity driver. There, and yeah, we can move that. And we should divide, not multiply. Let me make sure I'm not losing anything. There we go. So we have a budgeted 10,000 units of our activity driver for deconstructing, whatever that activity is, and whatever that driver is. And so that $550,000 that went to it, based on 25% administration, GL being consumed by deconstructing, and 50% of shop supplies being consumed by deconstructing, it leads to ultimately an activity rate of $55 per consumption of the deconstructing cost driver. Right now, we're kind of where we were at the beginning of this problem right here. I gave you the rates. Great, we got that far. They consume $200 of direct costs. I'm going to put that down here. I think we can deal with that a little later. More importantly, perhaps, is I'll push it up as we need to. They consume, I'll put a little space, 5 units of the deconstructing activity driver and 10 units of the disintegrating activity driver. So we can multiply. We can charge the job $55 per unit of deconstructing activity driver and $34.38. And I haven't rounded that off. I let it stay in Excel or in Sheets here as a big long number. Oh, it looks like one cent, one fraction, one decimal place. There we go. One place value past cents. That's how the question answer choices are almost always situated. So leave it in unrounded form until the very end if possible. And so we have a total overhead cost for this job of $618.75. Meaning we should have a total cost for Sabio job of $818.75. So that should be the right answer there. See anything I'm making a mistake on? Yeah.
Sorry, I think you just said this, but why is it 340.75? Why is that coming out to 8?
Are you dividing it by? You have 550 in the 550,000 in the numerator.
Yeah.
And 16,000 in the denominator.
Oh, okay, good.
Okay,
sorry.
no problem. Okay, other questions on this? All right, don't do anything with this. It's a period cost. Despite all our efforts to correlate as much of our overhead with individual product units, some things are just uncorrelated, or they're so noisily correlated, it's not worth tracking. So $500,000 of our overhead costs, we're just saying, oh, period cost, not worth tracking. Great. Let's scan on down here. Let's see. Another comprehensive question. So I got two comprehensive questions on the quiz. We can come back to that if you really want to. This one I think is just first stage allocation. Yeah, so the best way I can ask these questions sometimes is to have a variety of answer choices. Only one of them is correct. So let's go ahead and go through this in case it confuses you to see it kind of truncated from the total situation, or the setup of the question stem and the answer choices is a little different to you. So let's just make sure we go through everything here. We have our GL accounts. And again, I'll just copy the numbers over so I can use them. Put them in number format. Yeah, that looks okay, good. And I should be able to copy the table over nicely. And looks okay. All right. Great. And so I'm going to do the same thing I did before. Hold the column constant times the percentage. Control R to the right, Control D to down. Copy these down. So now we have our $1 million of drivers and security guards being allocated across here. Yeah, sums to $1 million. Great. Our permitting fees and packaging, $250,000, is being allocated to these different activities this way. Sums to $250,000. Vehicle cost, we had $1.5 million. Gets split up like this. Still sums. That's good. And our administrative costs, we started with $175,000. Get split up like this. Still sums. Great. Good check figures. So we can sum our, how did I do it right this time? Oh, I got it right this time. It can be taught. We end up with these activity cost pools. Planning activity, $445,000. Travel and security, $1.49 million. Dignitary services, $867,000. I'm rounding off some numbers. And other, $120,000. And it really is just asking us to stop there, because then it says which of these is true. And only one of these numbers is going to be accurate. And it's this one's ringing a bell here. Yeah, $445,000 is indeed the planning activity here. So that should be the right answer. Dignitary services, no, that's off. Travel and security, 2.5 million is wrong. That's 1.49 million. And here's a way of setting up the question that maybe throws you off. The budgeted overhead cost that would generally be allocated to services is $2,925,000. Okay, well, I don't see any of those numbers on here. So that might be, I don't think that's right. What that's asking is the product costs, which are these three activities. This is a period cost. It does not get allocated. So I'm asking, among these three cost pools, what is the sum? It's 2.805 million. It's not 2.925. So this one is wrong. It's not true, because these three activity cost pools don't sum to that amount. So when you see wording like this, like the overhead cost that gets allocated, you're looking at the activities, the activity cost pools for the activities that are that are not period costs. There we go. Everything but the other category, basically. Just sum those. It'll tell you which ones are allocated, which overhead costs we're going to allocate, because it's what we end up doing with these three. We did it up here. We took the non-other ones and we allocated them to the job. Sometimes it might ask period costs, or might phrase it the costs that are not allocated, and we're just looking at the other category. Just a different way of me asking whether you could get the other activity cost pool right. And other isn't, I use that terminology throughout. There might be other ways in which firms designate one or more activity cost pools without a driver. If it doesn't have a driver, there's no way for that cost to get to product units. So it's a period cost. For the questions, it's always going to be labeled as the other category for my questions. Looks like another first stage allocation question. And yeah, look, again, I have an answer choice that asks about the overall budgeted cost to be allocated to product units. So that would be the sum of these three activity cost pools that are actually allocable. All right. here I'm simply asking for activity rate. I'm not going to go through this question because it's the smallest jump I have in the. For one thing, it's the easiest once you see what it's asking. I'm simply saying here are the activity cost pools. Here are the budgeted driver. Right. There, cost pool, driver, and then I don't know the word budgeted in there, but that's what you're supposed to make of that. Then you just divide those to get activity cost rate. So in this case, the computer-aided design activity right here. It's that 1 million divided by 2,000. So I guess I kind of went over it with you. All right, this is an activity-based management one. It's kind of the odd man out, a little different. Let's come back to that if we want to. Oh, there's the Bubba Shrimp. Okay, there are varieties of this question, I believe. This one right here, let's look at it. This is ABM. We want to make sure we get at least one ABM question in. All right, so Bubba's custom shrimp catering. Oh, well, hold on. Let me read the question stem. Let's do good test taking strategy here. Let's do good practice here. Which of the following is the most profitable process improvement? Read the answer choices carefully. All right, notice a few things. I'll point out a few things that I already know is going to happen. Each process improvement costs the same amount. So if we're thinking about like a chapter 2 table, where there are different alternatives. We have 4 different process improvements, A, B, C, and D. Those are the 4 answer choices, A, B, C, and D. Each of them has a cost of $250,000 to implement. And so the question I have is the cost relevant between those 4? I see some shaking of heads. Yes, shaking of heads to be no. Yes, you're correct. It's no. The answer is no. It's not relevant because each one costs the same amount. If I gave you different amounts, which I don't think any of the questions do, and in reality you would have different amounts, then yeah, you have to factor that in. But good, I have this here just to kind of throw you off a little bit, perhaps. None of them change revenue. Okay, so I don't even think I give you the revenue Bubba Shrimp earns. So all we have is cost information. We're trying to find the most profitable alternative. So whatever number we come up with is going to be the total cost under that alternative. So we're trying to get the highest number or the lowest number. I guess somebody say lowest. Yeah, we want the lowest number here. I know it. If I lost you, let me just run through it real quick. We're looking for the most profitable. The only numbers we're going to be able to calculate are cost numbers. So the most profits come from the lowest cost. So we got numbers. All these numbers we're going to calculate. They're going to be real fun. Over here is going to be real fun. But we want to figure out which one gets us the lowest cost. And that by definition is going to be the most profitable given these 2 assumptions right here. All right. So let's run through our status quo. This is how I like to start it. Our status quo is that Bubba's Custom Shrimp Catering uses activity-based costing to determine the cost of its catering events. The firm has 2 activity cost pools, cooking, with an activity rate of $500 per catering event, and serving, activity rate of $12 per plate. All right, so I'll write those 2 down. 500, and that is per catering event, and 12, which is per plate. Now, we'll need a little bit of extra calculation there. We have 25 catering events a year, with an average of 50 plates per event. We also have $400 of direct cost. I'll have that in here, and we might move around when we consider that. Now we have 25 catering events per year. We have 50 plates. Well, per event. That would mean we have this many plates per year. In case you missed that wrinkle, our activity rate here is per plate, and we have a certain number of plates at each catering event. So this is our plates per year. This is our catering events per year. We can figure out our status quo overhead costs by multiplying these 2. These are our cooking activity costs. That's our activity cost tool for the cooking activity. And we can multiply the number of plates per year by the activity rate per plate right here to get our budgeted serving activity. So our total costs are going to be this direct cost and our two overhead costs right here. That's our status quo total costs. Okay, so what I'm going to do now is I'm going to copy it over. And we have now improvement 1. Reduce cooking activity rate by 25%. Okay, whoa, grab it. And let's see, I can do this pretty easily in Excel. Can I? Nope. I have to. Sheets is sort of fun. Okay, so we're going to reduce our cooking activity rate by 25%. Paste that value in. 25% here, 375 instead of 500. And our costs have gone down to 24,775. Now, if I did this and copied down for improvement number 2, I'd be making a mistake. What's the mistake? Yeah. I would be evaluating this right here with this 375. I would be evaluating this as if we got to do this and this. If you're doing it the way I'm doing it, copying my method here, always make sure you copy from the status quo. Right. We don't want to stack improvements because that's not what the question is asking for. It says you get to choose one improvement. So start from the status quo, go down that branch of the improvement, and then go back to the status quo, go down a different branch for a different improvement. Don't go status quo, improvement number 1, then further down that branch, improvement number 2, then further down improvement. You'll end up inevitably with the last one being the most profitable because you've got all 4 improvements. You'll always have the last one being right. And you'll be wrong at least 25% of the time, I would think. All right, this is reduce plates per event by 20%. Okay, great. We have 50 plates per event. 20% is 1/5, so I can type in 40. And so we have 24,900. It loses. These costs are higher than improvement 1. So right now, improvement 1 is the best of the ones we've analyzed. So far, that's looking pretty good. Let's see what else we can do. Setting it up takes a few seconds, and making sure you copy from the status quo each time takes a little mental energy. But the actual analysis is pretty simple and straightforward. I'm just going to copy down. Probably takes the longest for me to yammer on and write the names of them, which on a quiz or a test, you might not do as much yammering. How much you talk to your computer during the quiz or the test, I don't know. More than you. Okay, well, you know what? You're not too weird for that. At least I do that. Yep, I sit there in my room and I lecture to my computer. Same thing I'm doing here. All right, this one is activity rate by point. That's very undescriptive. We need to reduce which activity rate? Serving activity rate. Great. Serving activity rate is 12. 25% is 1/4, so we're going to reduce that to 9. So 3/4 of 12 gives us 9. We can multiply that out in a cell if we want and copy it over. We could, if you don't want to play fancy games, you could say that times 0.75 and then just say, oh, well, I'm going to change it to 9 now, since I saw it was 9. You don't have to learn the fractions in your head to get the questions right. 24,150 is the total cost now. We didn't stack anything, right? I still have, was the reduction here. Yeah, we didn't have that reduction, and we have still that as a status quo. Good. 24,150, what is that? Does that, it's in the lead now. It's now in the lead. Great. So now improvement 3 is currently the best we have available. Let's see what happens with improvement number 4. It's pretty obvious to me it's not going to do much because those direct costs are microscopic compared to the overhead costs. So reducing them by 25% is very unlikely to make it. Yes?
Should the direct costs be larger per event?
Yes, it should. Okay. Thank you. So let's add in a line. Thank you. I missed that. I don't know if it'll change the answer. Direct cost per event times the events per year. All right, so now we will change this to there. That should be right. Okay, and let's see if we can get this to play nice right here. No, it doesn't like that. How do I have to get this? Oh, I added to improvement 1. Why do I do that? Let's go back. Add it here. Maybe this will be easier. Direct costs times catering event per year. Okay. Change that up. Let's see if I can copy it down now. Okay, good. Just need to insert some lines. Okay, and now let's apply that in. Okay, so we should still have improvement number 3 leading before we get to the direct cost improvement, because all 3 of the prior improvements had the wrong direct cost number, but the same, it was wrong in the same way. So we've now changed the correct number, the direct cost number to be correct, and they all have changed from 400 to 10,000. So let's see, 33750 is lower than 34,500 and lower than 34,375. Yes, lower than 34. Good, so improvement 3 is still working. Now, thank you for correcting that before we got to improvement number 4. Let's go back to the status quo, and I got that in the status quo, good. Copy it down. Improvement number 4. So now my intuition about it being obviously worse is not as strong. Reduce direct costs by 25%. Okay, so reducing a $400 direct cost per event by 25% gives me $300 direct costs, $300 in direct costs per event. And so we have 35,000 as our total costs down here. 3 still wins. Now, if the logic makes sense to you, you don't have to go brute force like I did just now. This is a brute force method of looking at each alternative. What does it look like? You can do more of a differential sort of thing. At least the logic of it is more of a differential analysis than a total analysis. Of our 3 things that are being improved, 4 different ways. Because notice, so first of all, let me observe that these reducing the number of plates and reducing the serving activity are both improving the same number. One reduces, so it's this number right here. We're reducing this number either by, go back to status quo. We're either reducing our serving activity number by reducing the number of plates per event, or reducing the I wiggled the cursor over the wrong one. Reducing the number of plates per event, there we go, by 20%, or reducing the serving activity rate by 25% right here. So both of those are working on this number right here, and one reduces the number by 20%, the other reduces by 25%. So obviously it's going to be the one that reduces it further. And of our three numbers that go into total cost, that's the largest one. So if we're reducing it by 1%, and they're all at max being reduced by 25%, then this is logically going to be the right one. We're getting the biggest bang for our buck. So activity-based management, if we were to do a case about this, for example, one shortcut you could do, or if, in these questions, if the logic makes sense to you, you could say, well, all right, now that we have our activity-based information, our activity-based costing information, it tells us the magnitude of our different activities on the magnitude of the impact of our different activities on our bottom line costs, or on our costs that affect the bottom line. And so, yeah, we've got these three categories of costs. And look, because we went through all the first stage allocation to get to the activity cost pools, we know that this is just the biggest, it's the biggest bull in the ring. So this is the one we need to focus on reducing if we're going to make an improvement. And since all these improvements are held constant or are an inferior version of reducing this one, then this is going to be the best option. So you don't have to go brute force. If you can keep the logic straight in your mind, you're welcome to sort out status quo here and look at the different alternatives and say, well, which one is what number is it affecting and by what percentage? And probably the biggest percentage, the biggest number is what's going to give you the right answer, the biggest cost reduction. Okay, improvement number 3 was the right one we had here. So ever so slightly a better improvement than improvement number 1, which was the previous winner before that. Okay, questions on activity-based management? Yeah.
One question that can't really work out too well is finding what's ultimate profit that can be earned from customers.
Okay. Is it the 3 customers?
With the partner hours balance.
And you gotta drop one, right? Is it the Xavier, Young, and Zanes?
So that's almost like you have to drop one. You don't have a target category necessarily.
All right, let's see if we can find a question that's at least like that. How many we answered? 1, 2, 3, 4. We'll submit this. Hopefully we get 2.5 times 4, 10. Good. Okay, let's try and get another draw and see if we get something like that. So here's some customers. This is not what you're looking at. Okay. All right. We'll draw again. Right here. Okay. So I don't know if the numbers will match up exactly. So these numbers can vary sometimes from version of this question to version of this question. So the idea down here in the question stem is what is the optimal profit that can be earned from these customers? So we have these 3 customers, Xavier, Young, and Zanes, and the idea is that the firm has to drop one of them. That's embedded in here. It's an important detail. I haven't bolded it or italicized or anything like that, but it kind of sets up what we're trying to do. It's what makes it the optimal profit. I mean, if you didn't have to drop one, the optimal profit would be, we'll keep all of them that are profitable, all the customers that you're making money off of. Yes, as many as possible. Yes, and more. But we have to drop one just because I said so. Maybe there's a reason. I don't know. Maybe one of your partners is going to prison, so you don't have enough partner hours to serve all 3. That's really dire, but maybe that's the example. Maybe that's the situation. And so we have these 3 customers, and I embedded their revenue to us down here. This is our revenue per customer. This is the direct cost per customer. And then we have their consumption of 3 cost drivers, or activity drivers, and enough to create activity rates for those 3 activity drivers. All right, so we're going to go with this is another ABM question. The style is customer profitability. like I get that it's not necessarily the most realistic scenario to say you got to drop one. This isn't a game show. Most businesses aren't game shows. It's a cheap and easy way for me to make you do the calculations. It is contrived, but welcome to all college test questions, basically. And okay, before I rag on it too much, I almost came up about saying this when I was describing up here why exactly I have different types of questions the way that I do. And there is some method to the madness here. The idea is I'm trying to get you to learn these particles of knowledge, these subunits of knowledge about activity-based costing here, and be able to apply them and do them. But I can break them down. So I want questions that break down in a way so that you get points for knowledge if you know how to do this step. Maybe you don't have any idea how to get from here to here, but if you know here to here, you get points for it. So there are questions that just ask about that. There are other questions that ask about just from here to here. So if you know that step, great, you can get points for it. Maybe you don't remember whether or not direct costs need to be added or not. You can't get that question right. You can get this question right here, right? You can get points for that. So I'm trying to stratify your scores and the credit for what you earn on the quizzes and the exams based on your knowledge as granularly as I can. And so I end up contriving scenarios so you have to do certain calculations. That's ultimately the pedagogical goal here. All right, so here we have copied this over. I'm going to copy this over too. I think it will copy nice and clean. I'm generally happy about Canvas tables and how they copy over into, into Excel or Sheets here. That time I did want what it had. All right, so first off, I grabbed activity rates. Calculated that, and I'm going to apply those to these amounts right here. These activity driver consumption numbers right here. So I want to multiply my activity rate. I'll hold the column constant. I want to multiply it by what's happening. I think it migrated. By the consumption right here. So as I move to the right, the column's held constant with the activity rate, and so it'll stay here. But if I move down, it'll go down to the next activity. And I've got the three lined up here that are here. And there's the drivers. They're lined up right there. Good. So everything's lined up. I should be able to just copy over. Stop that.
Which control function do you use to fill it into the right? Okay.
Control R. Control R controls fills into the right. Control D controls down or fills in down. Yeah, it's one of my favorite. I just like that. All right, so now what I have is to name this. No, Google fails my class. It doesn't know which ones to add. This is our overhead cost. This is our total overhead cost by customer. So we can add in the direct costs. This is our total cost per customer. Now, just to make it more like a income statement, looking better, it makes more sense to us. I'm going to put the revenue up here. I'm going to create some extra rows, and I'll copy over 650,000 for Xavier, 1 million for Young, and 750,000 is our revenue from Zanes. Okay, then I can go down here and get our profit by subtracting away the costs from those. This is our profit by customer. Great. So Xavier's got to go. The weakest link, based on this contrived scenario, is the Xavier customer. So we're going to keep the two most profitable. We will keep these two right here, and that's going to be our optimal profit given the scenario where we have to drop one of the customers. Does that make sense, what we're doing? Okay, good. And that is one of the options. If you do all the calculations right, you will get this right here. Yes, H. Yes. I took the cost pool and divided it by the drivers, the activity drivers. from this table right here. And I didn't put budgeted in the heading here, but I did say it here. So these are budgeted numbers. So it matches well with what's in the textbook. Okay. Somebody who didn't watch the video is going to look at this and say, what in the world is happening in class? But then they'll watch the video and so they'll be good. Yeah, it looks like this. If you sum these two together, you would get another answer choice that's wrong. And if you sum these two together, you would get another answer choice that's wrong. I wasn't terribly creative with how best to distract you from these. That's the most powerful distractor. If you forget the setup of having to drop one, you end up with this number. There. More likely, if you make a mistake, you're going to make a mistake and not get any number on here. So, yeah. These two right here. I'll highlight them. Make it a softer yellow, not that screaming yellow that blinds your eyes if you're on mobile or whatever. Okay. So my plan, I'm going to start talking about 5-2 stuff. The weird ABC. I think I called it that even. Hurt its feelings. Let's see if it'll play nice with us despite me hurting its feelings. It's not really weird. It's just trying to simplify activity-based costing. These are, so yeah, by the way, I got the ABM types of questions are all driven by the textbook varieties of activity-based management here. Customer profitability analysis, product mix and process improvement analysis, process improvement, and some, I don't think I have many pricing decision ones in there. They're harder. It was harder for me to figure out a good way to test that. All right, so 5-2 is simply talking about section 5-5. The entire quiz is this part of the textbook and down. So there are ways to simplify activity-based costing, which is good because you get no gap points for activity-based costing. And if you can get largely the same improvement in your decision-making at a lower cost from the complexity of an ABC system, then yeah, that sounds like a better deal, right? So there are two different flavors of simplifications we have. One is time-driven activity-based costing, 5.5.2. And if we scroll on further down past examples and everything, we have the other flavor, which is 5.5.3, approximated activity-based costing. So TDABC gives you different activity rates compared to normal ABC or standard ABC. So it is a simplification of our first stage, which brings us up to activity rates. Approximated ABC, it's also a simplification, but after we've already calculated activity cost pools. We've done this business, and now we're going to rearrange it to simplify the number of activity cost pools we are tracing, so that when we get to second stage allocation, we're tracing fewer activity drivers. It's costly to trace 10, 20 activity drivers to individual product units. So let's go through both of them. So TDABC, I like to joke it came about because the ABC funds, consulting funds, were drying up for Kaplan and cohort, and so they came up with a new acronym to sell more consulting hours. And I'm teasing, he's a big Harvard professor, super rich, I'm sure, and so he can take my teasing from little old Idaho. But there is some use for TDABC. It's not entirely a grab of money. In fact, I'd say there's a good use for it in certain scenarios, and that's how they pitched it. So I'll give them credit. It's useful especially for service firms where specifically time spent by professionals or a particular machine, if it's like a specialized machine, is what adds value, especially value related to overhead. So what we're going to do is we're going to take we're going to throw out a bit of our typical first stage allocation and instead drive overhead costs through the prism, the filter, now use those two, the prism or the filter of our constrained person or machine, just to bring up some constraint kind of ideas, and then use that to figure out activity rates per our different activities. Now, let's show you what I mean. So first thing is we need to figure out how much it costs us in overhead per unit of whatever the constraint is, whatever the critical or key person, people, or machine is. So if we're in a doctor's office, we have a doctor, and you know a doctor's office, presumably, unless you're super healthy, I don't know, you've been to a doctor's office in your life. The doctor comes and sees you about 30 seconds, and then but bills you a lot, or bills the insurance a lot. And yeah, the doctor maybe one of the reasons for that is their time is the main value added of the doctor's office, a principal component of it, and so their time is the critical capacity that they're interested in. So they're going to meter it out in the office there as efficiently as possible. And so the doctor will be the denominator, the doctor's hours in that case. If we're in a nursing department, the nurse hours. If we're in an engineering firm, the engineer hours. If it's some critical machine, the machine hours available, that's the denominator, and you divide all overhead costs by that denominator to get the capacity cost rate. All right, so how many dollars of overhead are we assigning to an hour of the critical capacities, the time, basically. If I can call a doctor a capacity. And then, instead of doing a big percentage table, we have a simpler ABC study that can happen. We're just going to determine how much each activity, how much time of the doctor or the nurse or the engineer or the machine each activity uses. So we get our department per process time per activity driver unit. That's great. I'll come back to that in a second. And then we calculate activity rates by simply multiplying capacity cost rate by our department/process time per activity driver unit. I see. I apologize. I read that as division. No, department or process time per activity driver unit. And when I say department or process, I'm talking about like activities, like we would do in standard ABC. We have different activities. And how much does that activity or the department or process consume of the critical persons or things time? Multiply the capacity cost rate by that, and you get activity rates. So our activity is driven by this metering out this critical capacity to the different activities. That's why we're like filtering down all overhead through the prism of, or lens or whatever, of this critical capacity. All right, so the example is pretty good. I like the example here. We've got GL accounts. Oh, that looks familiar, but we don't have a percentage table. Instead, we have 2,000 mechanic hours. So we are in this mechanic department or maintenance department and mechanic hours. That's the critical capacity we're interested in. And so we're going to divide the sum of these total overhead costs, because these three are our overhead costs, by that 2,000. And so we end up with a capacity cost rate. That's step one. That's the critical term. Some of the questions in 5-2, as you'll see at latest by noon tomorrow, ask for you to calculate capacity cost rate. And you would stop right here if it's doing that. You would just come up with, hey, here's the number. Total overhead divided by the critical capacity. 127.5 overhead cost per mechanic hour. Great. Now, instead of a percentage table, we're going to take these two activities. I'm copying over from section 5.3, the earlier section in the chapter. We have machining and finishing, two activities. And so they're still driven by their respective activity drivers. But instead of having a percentage table, we figure out our activity-based, our TDABC study comes up with these two numbers. These are the two critical numbers here. We need to know that each machine hour, which is the driver for machining activity, consumes 1.25 of mechanic hours. Right? That's our critical constraint time. And we're going to charge the machining activity 127.5 per machine hour. And we figure out, 1.25 mechanic hours are consumed. And so sure enough, we're going to charge for machine hour 1.25 mechanic hours times the cost of mechanic hours, the capacity cost rate, 159.38. And then repeat that for finishing, which has batch starts as its driver. And our TD-ABC study comes up with, 0.75 mechanic hours are spent per batch start. And so we're going to take that 0.75 times the capacity cost rate, and end up with our new activity rate for the finishing cost of $95.63 per batch start. And then we would go ahead and charge jobs based on how many machine hours they consume and how many batch starts they have. Underlying this is the mechanic hours that are kind of filtering in to these two rates right here. The terminology is a little different. The logic is slightly different. Hopefully, though, when you look at the steps, you can see that really it's a division to get this. I give you this, and you can multiply to get the activity rates. There is a simplification. We literally are doing fewer multiplications than right here. We have reduced the amount of calculation required. And you're like, oh yeah, but Excel can do it very quickly, or an ERP can do it especially fast. Well, yes. But I gave you these numbers out of the goodness of my heart. Each one of these numbers would cost money to collect and keep accurate and up to date for the business. So if we can reduce the number that we have to go do studies about and update, we can now have, we just need to do our TD-ABC study to figure out where are they? These two numbers, there we go. Okay, we have indeed simplified and probably reduced the cost of our system. Approximate ABC, we can cover this in global aspect, a general aspect in 6 minutes here. So in this case, we already have activity cost pools. So let's go down to the example real quick. I'll show you. We already have activity cost pools. We've got 3 of them in this example. Nope, 2 right here. This is a very, very simple example. We have 3 activity cost pools there. I've aligned it where the activities are rows. So these are our activity cost pools, and we can take our activity cost pools. I don't want to use this example. I want to use a different example, and I can still do it in time, I think. So 5-2, made up example. So we have cost pool A, B, C, D, didn't want E. And we have random numbers in them. Okay, let's even make that a little big here. Basic idea is there are 5 cost pools here. We're going to have to track 5 cost drivers to allocate all of these costs to cost units. Each cost driver that we are tracking costs us time and money. And so what if we could reduce the number of cost drivers we are tracking and still keep, in large part, the accuracy? We're going to approximate the ABC system. Well, notice that there are 2 really big cost pools compared to the others. In fact, because I'm in charge of the numbers right here, I'll even make it more so. There are only 2 of them that are in 6 digits. Make it easier to see. These 2, they're the big ones. They are the high dollar costs. So what we're basically going to do with approximate ABC, we're going to sum up all the low dollar cost ones and sum up the high dollar cost ones. And let the high dollar cost ones eat the low dollar cost ones. It's like a nature documentary, basically. And they eat them in proportion to their size. So, of the high dollar amount, cost pool B is 300,000 of the 800,000. It's 3/8, 37.5%. Cost pool C is bigger. It's going to be division. 5/8, 62.5%. It's $500,000 of our high dollar cost pool amount here. And so, and we'll move these over further. That's why I wanted to cut it, so that references would stay. And so what we're going to do is we're going to say, all right, you get to eat 37.5% of the low dollar cost. You get to eat 62.5% of the low dollar costs. So you're now not 300,000, you are $358,875 as your cost pool. And we're going to use that as the numerator for cost pool B's activity rate. And we're going to push out costs based on a consumption of activity B's cost driver. Cost pool B's activity rate driver. Yeah. And now you're no longer $500,000. You're $500,000 plus the $98,000 here. So you're this amount. And we're not going to trace A, D, or E's activity drivers at all. So the question is basically, how do you do this kind of thing? Some of them ask you to contrast. 5-2 questions will sometimes ask you to contrast normal ABC or standard ABC against approximated ABC or TD ABC. So you'll have to figure out a number with this versus the similar number in standard or normal ABC. All right, we'll talk more about that on Wednesday. Thank you.